Right, so last topic in this chapter and in this unit is taking an nth root of a complex number. Now we're only going to take the square root in this class, but this is how you do it in general. So if you're taking any complex number to the 1 over nth power, well, again, the r does what you think it would do, because again, you're taking the square root of the entire thing. So you take the, or nth root of the entire thing. So you take the nth root of r, and then as the n, which was a positive integer, was multiplied by the angle, 1 over n is going to be multiplied by the angle as well. So really what you see here, this bit here, this is really just cosine of theta over n. And then the plus 2 pi k, essentially what we're going to do is there's going to be a total of n different roots, and they're all going to be equally spaced. So k is going to be the number of different spots that we have other than the original. So we're going to find one solution, and then from that one solution, we'll be able to find the rest of the n minus 1 solutions. Again, we're just going to do a square root, so I'll show you how the square root works, and we can extrapolate that a bit to a cube root and so forth. So let's do a couple problems from your suggested homework assignment. Let's do number 31. And this is 4.5. Number 31, 46. All right, so we want to take this, the instructions say take the square root. So essentially what we want is the square root of 2i. This is what we want to do. So first of all, 2i is right here. Now, these are imaginary. These are the reals. 2i is right there. Calculating r is very simple. It's 2 away from the origin. So here, r equals 2. And r is calculated, the distance, right there. I mean, you can run the square root formula. It will work for you. We don't have to do that because it's a nice, easy, calculable one. Okay, so we've got our r. We know what angle that is. That's pi by 2. So we know theta equals pi by 2. So putting it into trigonometric form, scroll down a little bit. So 2 pi equals 2, and then the cosine of pi by 2 multiplied by, added plus I sine of pi by 2. So if I'm taking the square root of this, and we take the square root of all of that. So that's to the 1/2 power, essentially. So just like we did before, we're going to bring the 1/2 down. So let me just rewrite that. So this should be 2i, not 2 pi, I'm sorry. So this is 2 . So we're simply going to bring the 1/2 down here, multiply by that, multiply it by this, and raise the 2 to that power. So this equals root 2. And then we've got cosine of pi by 4 now, because pi by 2 times 1/2 is pi by 4, plus I sine of pi by 4. And now we simply convert it back to standard form. So that's root 2 and cosine of pi by 4 and sine of pi by 4. Well, pi by 4 is in quadrant 1. And these are going to both be root 2 over 2. And don't forget the I. So when we multiply through by root 2 and root 2 in the numerator turn into a 2. We've got 2 over 2, so it's just 1. So this equals 1 plus I. So the square root of 2I is 1 plus I. Now, as we know, when we take a square root, we get two different answers. You take the square root of 4, solving for x, you get plus or minus 2. The square root of 4 is just 2, but when you're solving for x, x can have be negative 2 or 2 to get that answer. Anyway, I digress. So our answers, we found one here. So this is going to be 1 plus I is going to be one answer. Now, if we go around exactly halfway around the unit circle, we're going to get another answer equidistance apart, and it's going to be negative 1 minus I, or negative 1 plus I. So plus or minus 1 plus I. So those are our answers. So how this would work if this was a cubic root instead and this was a solution, we would break the unit circle into thirds. And instead of going 180 degrees, we would go 120 instead. And that's how that works. And if it was a fourth root, we would break it into fourths. We would go 90 degrees or add a pi by 2 to each one. But again, you're just going to take a square root.